Welcome back to the deep dive. Today, we're taking a look inside supply chain optimization, specifically how businesses using SAP Integrated Business Planning, or IBP, get really smart about differentiating their products.
Yeah, we're focusing on ABC XYZ segmentation. It's, pretty foundational if you want to get beyond just basic planning. If you really want to dial in your inventory, your forecasting, this is where you start.
Right, and it boils down to classifying products based on, well, two main things.
Two critical dimensions, exactly. First, there's its value to the business. That's the ABC part.
Yeah.
And second, how predictable its demand actually is. That's the XYZ side.
Okay, so let's break down that first one, ABC. This feels familiar, kind of like standard business thinking, value-based.
It is. It's often tied directly to revenue, maybe profitability, or sometimes just strategic importance. It really comes from the Pareto principle, the 80-20 rule everyone talks about.
Ah, right, so the A-class items, they're the heavy hitters, the minority that brings in the majority.
Precisely. You're looking at maybe 10, 20% of your total items, but they're pulling in, say, 70 to 80% of the revenue. These are the ones you watch like a hawk. Highest service levels, tightest control.
Makes sense. And then B-class, middle ground.
Yeah, the solid performers. Maybe 20 to 30% of your items contributing around 15 to 25% of the revenue. Dependable, but not superstars.
Okay, which leaves C-class. Loads of items, but not much value.
That's the long tail. Exactly. Could be 50, 60, even 70% of your skis, but maybe only contributing 5 or 10% of the total revenue. You manage these differently, often with, simpler, more bulk strategies.
Got it. Okay, so that's value. Now, the other side, XYZ, you said this is about predictability. Less about cash, more about headaches.
Yeah, you could put it that way. It's all about demand variability. How much does the demand jump around? Can we actually predict it?
So X-class would be the easy ones.
The dream items for planners, yeah. Highly predictable, very low variability. Think staple goods, consistent consumption, smooth sailing.
And Y-class, a bit more fluctuation.
Medium variability. Things like seasonal products, maybe items impacted by promotions. The demand moves, but you generally know why and when. It's predictable fluctuation.
Which brings us to the Z-class. I'm guessing this is where the aspirin comes in?
Z-class is the wild card, definitely. Highly unpredictable demand, lots of variability, maybe items with really sporadic sales, or things with terrible forecast accuracy historically, maybe new products. These need totally different rules for safety stock, maybe different forecasting methods altogether, because your standard approaches just won't work well.
Okay, that really sets the scene. ABC for value, XYZ for volatility. So let's get into part one. How does SAP IBP actually do the ABC part? What do we need to tell the system before we hit go?
Right. Before you can run the segmentation job, you need to configure the rules. Two absolutely essential pieces of information. First, the target attribute. You need to tell IBP where to put the result. Like, should it write A, B, or C into the attribute called OBC code, or maybe one called category?
Okay, so just defining the output field, what's the second crucial bit?
This is probably the most fundamental choice you make. The segmentation measure. This is the key figure, the actual data that the system will analyze. For ABC, are you basing it on actuals revenue? Or maybe actuals quantity? Or even gross margin?
Okay. So choosing actuals quantity versus actuals revenue, that could give really different results, couldn't it? You might have a high volume, low margin item looking more important if you just use quantity.
Absolutely. That's a key consideration. Sometimes companies run multiple segmentations using different measures like revenue and profit and then combine the insights. But sticking to the core methods for now, once you've picked your measure, say revenue, the classic approach is method A by Pareto principle.
Right. This is the ranking method we talked about. Sort everything by revenue contribution, then slice it based on cumulative percentages.
Exactly. You define the thresholds. Like in the source material example, A items are those that make up the top 70% of the cumulative revenue. B items are the next 20% cumulative, so from 70% up to 90%, and C is whatever is left, the final 10%. It's all relative.
Let's use that P1, P2, P3 example to make it concrete. P1 brings in 41% of the total revenue. P2 adds another 24%.
Okay, so together they're at 65% cumulative. Since our A threshold was 70%, both P1 and P2 easily fall into the A class.
Right, but then comes P3, contributing maybe 16% on its own. When you add P3, the cumulative total jumps to 81%.
And boom, that crosses the 70% threshold for A. So P1 and P2 are A, but P3, even if it's a decent contributor, gets classified as B because of where it falls in that cumulative ranking. It's not about its absolute value.
Okay, that relativity is key. But what if your business reality doesn't fit a neat 80-20, or you want certain high-value items to always be A no matter what?
Great point. That's where Method E comes in. By segmentation measure, single values. It's a very different philosophy.
Well, so.
Method E completely skips the sorting and the cumulative ranking. Instead, it looks at each item individually. You, the user, set hard absolute thresholds based on the segmentation measure.
So instead of percentages, it's like any item with revenue over $500 is an A item, period. Anything between $300 and $500 is B, and below $300 is C, like that.
Precisely. The big advantage, consistency. Let's say your total market booms and suddenly a bunch of items have higher revenue. In the Pareto method, Method A, an item previously ranked A might get pushed down to B just because others grew faster. With Method E, as long as that item still clears its $500 threshold, it stays A. This gives you more stable planning policies for specific items, regardless of overall market shifts.
That's a really important distinction for planning stability. Okay, and there's one more ABC method mentioned. Method F, K-means. Sounds like machine learning.
It is. K-means takes a different approach again. You don't set the thresholds, either relative percentages or absolute values. Instead, the algorithm looks at the segmentation measure values for all your products and automatically groups them into clusters or segments where items within a cluster are similar to each other.
So it finds the natural breaks in your data.
Essentially, yes. It's useful if you're not sure what the right threshold should be, or if you suspect there are natural groupings in your product portfolio that aren't obvious. It's more of a data discovery approach to segmentation.
Interesting. So method A is relative ranking, method E is absolute rules, and method F is algorithmic discovery. Okay, that covers the value side. Let's switch to part 2, XYZ segmentation, the predictability piece. How does IBP figure out if demand is stable or all over the place?
Similar to ABC, there are different ways to calculate it. Strategy 1 is called calculate variation. This is where the system looks directly at the historical demand data during the segmentation run and measures how much it fluctuated. It's calculating the regularity, or lack thereof.
And the main statistical tool for this is the coefficient of variation, or CV. Can you simplify what that tells us?
Sure. The CV basically measures how much your historical demand varied compared to its average level. Think of it as the wobble factor. A low CV means the demand was very consistent, tightly clustered around the average, very predictable. A high CV means the demand was scattered, inconsistent, jumping around a lot relative to the average.
Right. Like in the example, product P1 has a tiny CV, maybe 5%, so it gets classified as X-stable. But product P3 has a huge CV, say 70%, making it highly unpredictable, so it gets slapped with a Z.
Exactly, and you set thresholds for these CV values. For instance, you might define X items as any product with a CV below 0.3 or 30%, and maybe Z items are anything with a CV above 0.75 or 75%. The calculated statistic directly determines the XYZ code.
Okay, that makes sense for measuring the inherent stability of the demand itself. But there's another way, strategy 2. Aggregate over periods. How is this different?
This one's quite interesting because it shifts the focus. Strategy 2 doesn't calculate variation from the raw demand history itself. Instead, it uses metrics that have already been calculated elsewhere in IBP, typically by forecast error calculation tools.
So it's not looking at demand variation, but at how well we've managed to forecast that demand in the past.
You got it. It's classifying based on historical forecast accuracy, not just raw demand volatility. The system collects historical forecast error data. Often the mean absolute percentage error, or MAP, is used. MPE tells you, on average, what percentage error you had in your previous forecasts for that item.
Okay, so it gathers this MAPE data over several past periods.
Right, and then it aggregates, maybe it takes the average MAPE over the last 12 months, or the maximum MAPE, or the minimum, depending on what you want to focus on.
So let's contrast. Using average MAPE, item P3 might have had very stable demand, low CV, but for some reason our forecasts for it were always way off, giving it a high average MAPE, maybe 70%.
In that case, under strategy 2, using average MAPE, P3 would be classified as Z, not because its demand is inherently wild, but because our ability to predict it has been poor.
Whereas item P1 might have had slightly more variable demand, higher CV, but our forecasting model handled it beautifully, resulting in a low average MAPE of, say, 5%.
Then P1 would be classified as X under this strategy, because we've proven we can forecast it accurately even if the demand itself isn't perfectly flat.
Wow, okay, so the choice between strategy 1, CV, and strategy 2, MAPE, is really about what you want the XYZ code to reflect. Is it the nature of the product's demand or the performance of your planning process for that product?
Exactly. They measure different aspects of predictability. A high CV might lead you to accept higher safety stocks. A high MAPE might trigger a review of the forecasting model being used for that item. Both indicate variability, but they point towards potentially different solutions.
That nuance is really powerful. Okay, let's bring it all together in part 3, the actual system workflow. We've defined our ABC rules, say Pareto, and our XYZ rules, say calculate variation using CV. What's next in IBP?
Well, the process is pretty systematic. You bundle these rules into something called a segmentation profile. This profile holds all your configuration choices, the measure, the method, the thresholds, the target attribute. Then you set up and run an application job in IBP. This job basically tells the system, okay, take the segmentation profile, apply it to this set of products using this historical data, and calculate the ABC and XYZ codes.
We don't need every mouse click, but what's the key outcome here? Why is running this job and getting, say, A written to the ABC code attribute so important?
That's the crucial link. Once that job runs and writes A or X or CZ into those target attributes, those attributes essentially become part of the product's master data within IBP. They are now available to drive everything else.
Drive what specifically? How do these codes immediately impact planning?
They can automatically trigger different planning policies. Take an item classified as AX, high value A, and highly predictable X. The system could be configured to automatically assign it a very high target service level, maybe 99% because it's valuable, but because its demand is stable, X, the calculated safety stock needed to achieve that service level, might actually be quite low.
Okay, and the opposite, a CZ item.
Right. C for low value, Z for highly unpredictable. The system might automatically assign a lower service level target, say 90%, because it's less critical. But crucially, it might also trigger a much higher safety stock calculation method, or maybe switch it to a completely different replenishment policy, like a simple order up to max, specifically designed for volatile items.
So the segmentation job isn't just labeling things. It's actively setting the parameters, safety stock levels, service targets, maybe even the forecast model used for downstream planning calculations.
Precisely. It automates the application of differentiated policies across potentially thousands or tens of thousands of SKUs. You can't do that manually. You set rules like, any item classified as AZ, high value, unpredictable, must use the Croston's forecasting method for intermittent demand and requires manager approval for safety stock changes.
And then the final step is just seeing these results, right? Refreshing your Excel planning view.
Yep. Once the job finishes, you refresh your view in the IBP Excel add-in, and voila, the category attribute now shows AX, BY, Cs, etc. The classification is live and immediately usable by planners to filter, sort, and understand their portfolio based on this combined value and variability.
It lets planners focus their limited time, doesn't it? Instead of treating every item the same.
Exactly. You spend your time on the tricky ones, the AZs, the BZs, the items with high value and/or high uncertainty. You don't need to waste cycles meticulously reviewing stable, low-value CX items every week.
So wrapping this up for our listeners, this deep dive really shows how getting this classification right, combining the ABC value dimension with the XYZ predictability dimension, is fundamental. It gives you that AX, BY, CZ language to speak about your inventory in a much more nuanced way.
And it leads directly to smarter decisions about where to hold inventory, how much safety stock you really need, and where to focus your forecasting efforts. It impacts working capital, service levels, the bottom line.
It definitely moves planning beyond a one-size-fits-all approach.
Yeah.
But that leaves us with a final thought, something for you to mull over. We talked about those different ABC methods, Pareto, method A, fixed thresholds, method E, and K-means, method F. If a company decides to move away from setting their own fixed value thresholds, like in method E, and instead adopts the machine learning approach of K-means, letting the algorithm find the segments, what kind of shift in their underlying planning philosophy does that signal?
That's a great question. Are they moving from a world where the business explicitly defines what matters through set rules to one where they trust the data and the algorithms to reveal the inherent structure and groupings within their product portfolio? It's kind of a shift from top-down rules to data-driven discovery.
Rules versus discovery. Something to think about next time you're setting up a segmentation profile. Thanks for digging into this with us today.
And if you're dealing with similar challenges, perhaps struggling to classify your products effectively or unsure how to balance demand variability, we'd love to connect. Our SAP IBP consultants at Bestowal Systems and Services are always ready to guide you, share insights, and help you find the right solution for your business. If you found this episode helpful, make sure to subscribe and stay tuned. We'll be bringing you more real-world discussions, expert advice, and practical tips on SAP and digital transformation. Until next time, keep planning smart and growing stronger with Bestowal.